All right, class. So continuing off of our topic from Wednesday, we're going to do a couple more Punnett squares together. We're going to do some Punnett squared word problems together, and then your assignment, your e-learning, will be doing our last word problem, Punnett square word problem on your own. So let's go through a few more examples. Because of some of the feedback I've gotten about these Punnett squares, I wanted to take some time to explain a few things. If a parent is considered homozygous dominant, that means both letters will look capital, like this. If a parent is considered homozygous recessive, both letters will look lowercase, like this. And if a parent is considered heterozygous, its letters will look like this. If any pair of alleles has a capital letter in it, like this or this, it's gonna show the dominant trait, like tall in these two examples. The only time we ever get short is when it looks like this, homozygous recessive. So let's do this problem together. We're crossing a homozygous dominant parent with a homozygous recessive parent. So a tall parent and a short parent. If we bring all our letters down, it'll look like this. Instead of big T's and little t's, like the parents were on the side and the top, every single possible offspring is big T, little t combined. Ace, rude, ace. So that means 0 big T's, all 4 big T little t's, and 0 little t's. Because there's at least one big T present in each of these, that means they're all 4 gonna show the dominant trait, tall, and none of them are gonna show the short trait. That leads to 100% tall. Pause here. You guys try this Punnett square, and I'll give you the answers in one moment. Boom, here's our answer. If we cross 2 big T, little t parents, we end up having 1 big T offspring, 2 big T, little t offspring, and 1 little t offspring. This means 1, 2, 3 of the possible offspring are going to be tall, and 1 are short. So these 2 tall parents had a kid that, or can have a kid that's gonna be short. All right, so we're gonna work through 2 word problems together, and then your e-learning assignment will be figuring out the third one. So for this first word problem, using the examples on the front page, we're gonna create a Punnett square for each problem to determine the genotypic, that's the letter combination, like big T, little t, and the phenotypic, that's the actual physical trait, like tall and short, ratios. Our answer should look like on the front, but because we're going to find different traits, we'll use different letters. So one cat is heterozygous for its long hair, whereas its mate has short hair. So let's break that down, what that means. Heterozygous. That means that it's going to have 1 big letter and 1 small letter. Because we're dealing with long and short hair, we'll just use H's for hair. So that means the heterozygous parent is going to be big H, little h. And its mate has short hair. Now, a heterozygous parent is always going to show the dominant trait, and that's long hair. That means the short hair, remember the only possible combination for short hair, if it's recessive, is double small letters. So we're going to need to create our own Punnett square with one parent being big H, little h, and the other parent being little h, little h. So if we do our cross, this is a 50% chance that the kid is going to have long hair and 50% chance that it's going to have short hair. I know that it's 50% to be long because there are 2 of the 4 results that have a big H, and 50% for short because that's 2 of the 4 results having both little h's, and that's the only time there's ever gonna be the recessive trait, in this case, short hair. Alright guys, one more problem together, and then you guys can try problem 3 out on your own. So for problem 2, in superheroes, super speed is a recessive trait. So let's start there. Super speed, gonna be little s, that's recessive. Mr. Incredible and Mrs. Incredible both have normal speed, but their son Dash has super speed. So this means that normal speed can be big S, little s, normal, or big S, big S. So we need to create a Punnett square that's going to show how 2 parents that have the dominant trait can have a kid with the recessive trait, super speed. Now I can take a parent with homozygous dominant, big S, and right there, we're not gonna make it work. Because if I bring a big S down to each box, no matter what happens, that kid's gonna end up with normal speed. So, beep, bop, boop, beep, boop, boop. We know that our parents are gonna be big S, little s's. They're still gonna have normal speed, but they can have one box that could have a kid with super speed, like Dash. I know that this video is already going pretty long, so let's jump right to it. Your e-learning is going to be problem number 3 about the mantis shrimp, one of my favorite critters in the entire world. If you still need extra help, more extra practice, try 4 and 5 as well, but question 3 is the only one you're gonna have to turn in. If you guys need any help, please let me know. I'll gladly set up a Google Meets with you to help you. Just email me and we'll get that set out. Peace.